Good morning, good afternoon, good evening, everyone. Welcome to today's webinar, Production Ready Container Networking with Mesosphere and Big Switch. This is Judy Ash. I'm head of corporate marketing here on the Big Switch team, and I'm your host for today's program. Joining us is Amir Abdelrazik, Director of Product Marketing for Mesosphere, our own Bala Ramachandran, Director of Product Management at Big Switch, and Don Giacotti, our technical marketing engineer from Big Switch team as well. As we go through today's presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this in a rebroadcast or on demand and you have questions, please send us those questions at info@bigswitch.com. We've provided a number of handouts as usual for today's session, and it's easy to download them from the handouts tab on your dashboard. We have a very full agenda for today's webinar, so let's get started. And we want to start off today's webinar by getting to know how you're using containers. Please take a minute to answer the poll question. How are you using containers today? Just select one or more of the following, from a range of just getting started to I have many applications in production starting now. And we see them rolling in. Bala, Amr, any idea on what's going to be most popular?
I think the option of people just starting out with containers and early plans is what I would expect.
I would say the first two. Since a lot of people are evaluating, trying to figure out their strategy now, but we may also have some experienced users with applications in production. So let's see.
Let's see. I agree with you. At various container events, what I hear on the floor from folks is that they're any range from researching to some really on the edge of using containers to advance their infrastructure. And those that do are finding there's tremendous agility. So let's see what the results are. How prescient of our team. The majority, almost 70%, are just starting out or planning to use, at least those on today's call. Some are using containers in development only, so it really is the top two. And a few on the edge, the cutting edge of having a few applications in production. So I think that's a great start. And thanks for taking a minute to engage with us and give us some insight as to where you are. Let's talk a little bit about Mesosphere, and then I'll hand it off to Amr. Mesosphere delivers cloud-independent digital transformation with a platform that runs modern enterprise apps in on-premise and cloud-based infrastructure. Businesses accelerate new initiatives with cloud-native technologies, while IT retains independence to run their data center or cloud-based infrastructure with no fear of lock-in. Mesosphere is the only production-proven and fully supported platform that elastically runs containerized apps and data services at scale. Let me hand it off to Amir, and let me also state that Mesosphere is a great partner with Big Switch. We do lots of work with joint customers to drive containerized applications. And so with that, I'm going to hand it off to Amir. Thank you.
Thank you very much. And thank you for the time, everyone. I want to set up a little bit of context about what we're trying to do and what most of our customers are trying to do. So the way we see a lot of our customers and the market is they're trying to solve kind of three big problems. The first problem is around containers and microservices. So that's one problem. The second problem is probably around data, fast data, machine learning, and AI. And the third problem is like, okay, as we have these, trying to build these rich applications using microservices and data, where do we run them, and how can we put it and what's our hybrid cloud plan, on-premise, on the cloud, all that. And one thing we do is actually, this is kind of where Mesosphere comes in, is we work in the intersection of all of these. So if you click next, please, you can see that what we are trying to do is trying to help you instead of like you're having an only option on the public cloud providers, which are great, but again, we're trying to help customers have a lot of options in how they run and how they use the application, and get the portability and get the flexibility to run whatever they want anywhere they want. In order to do that, I think what introduced with Mesos, I mean, Mesosphere is the company behind Apache Mesos, and a lot of people don't know that. What we are trying to do here is trying to break in from what your traditional approach of building infrastructure. So again, if you're thinking about how application or clusters being built, you probably have a cluster for your data service, another like Cassandra, another cluster for Kafka, another cluster for Kubernetes, for example, another one for Jenkins. And what ends up happening, you have a lot of manual and application-specific configuration that is very slow. You have cluster sprawl, and you have low utilization, which at the end is, if you take a step back and why are people trying to go to container, they try to go to containers to get to speed, to get things faster. So if we can find another approach of how to bring things faster to market and bring these technologies, we can build a lot of amazing applications, and our application teams can do this in a more efficient way, and our infrastructure team can do this in an easy way. So what we propose from a DCS approach is, the idea is you're using your entire capacity of your data center as a cloud as one giant computer. So you don't have a specific application or cluster silos. You have one pool of resources that is already aggregated, and you can use it for container orchestration, analytics, and message queuing. And then you can actually have a lot of application-aware automation. You can pull the workloads together, and you can run them on any hybrid cloud. So this is what allows you to accelerate innovation. Again, we want to empower IT to have these as a services. Again, if you think about what you're trying to do with containers now, you want to offer Kubernetes as a service, maybe internally or externally, or you want to offer that across hybrid clouds. And that's what we do with Mesosphere DCS, and we enable you to do that. We're going to show that in the demo and some of the things we have. A big question we have is like, okay, how is Apache Mesos different from traditional container as a service technologies? And the way we'd like to think about it is when Apache Mesos is oftenly confused with container orchestration, but it's because of its two-level schedule architecture, it actually allows it to decouple the infrastructure. Its prime rule is to decouple and aggregate the infrastructure. But then on top of that, you can run microservices, you can run container orchestrators itself, such as Kubernetes, you can run data services, you can run all of these technologies independently. And now managing these technologies is decoupled from managing the underlying infrastructure. Compared to, for example, where your approach as container orchestration, now your container orchestration running our application and managing the underlying infrastructure as well, which makes it easy to manage a lot of these technologies, and which kind of brings you back to the silos approach that we're having. So if you want to run Kubernetes, so this is what DCS provides. Mesos automates the Kubernetes lifecycle. So you have a one-click deployment, as we're going to show you. You get high availability, security, scaling, and upgrade. A lot of best practice encoding, similar to what you have from a public cloud experience. We also allow you to run multiple Kubernetes cluster on DCS. So again, you can offer Kubernetes as a service. And what happens is you may have one or two teams, but at the end of the day, you may be having different technologies running. You want to have dev, test, and prod. You may have different projects even for the same team. So that's a scenario where IT organizations want to manage different Kubernetes as a service cluster for each, and you want to offer that on-premise on the cloud as well. And finally, of course, you want to couple that with an entire CD pipeline that is shared resources. Again, so things like Jenkins or many of these technologies, you want to use them in a way that integrates that, and you don't have to run them in a different cluster. You can run everything on. So that's kind of the benefit on DCS. So that's kind of the benefit and why we would run DCS on Kubernetes on top of DCS, excuse me. So going a little bit technical is like, okay, what's happening in the background? We talked a little about the two-level scheduling and the automation. So what's happening, if you think about the steps you need to do to deploy a Kubernetes cluster, these are just from Kubernetes up and running, and these are like 21 steps from prerequisites to etcd to DNS and naming and all that. That transfers from DCS is a cloud-like experience. So the command we do is DCS package install Kubernetes. That is the experience of deploying a Kubernetes cluster on top of DCOS. And that's the experience we want to have for you, so that you don't have to worry about a lot of these issues and capabilities. You don't have to worry about you don't have to get a PhD in Kubernetes. You just get a one command and all the best practices up and running.
I have a question here. Why would I want to run Kubernetes on DCOS compared to running Kubernetes standalone or in the cloud?
Thank you. That's an important question and a great question. So what we see is a lot of the customers try to manage multiple Kubernetes clusters at the same time, or actually automate the lifecycle. Because Kubernetes is a very fast-moving project, you have a lot of moving pieces. Trying to get control of these pieces, for example, in 1.8, you're going to have a different experience in Kubernetes 1.9. You're going to have a different experience in Kubernetes 1.10. So trying to get a hang of all of this in such a fast-moving project is key. So that's why the automation helps you accelerate the lifecycle and encodes a lot of the best practices for you. So that is one. The second piece, of course, is offering Kubernetes as a services to the customer across in different teams. So that's also something, if you can offer it in an easy way and share the resources, that makes it a much better experience and easier to operate for the infrastructure operation. So again, just to show you, this is the experience looks like. Again, it's a single click deployment. It just fast forwards and you get all the components of Kubernetes up and running. We can actually cover more of that, a slight bit of that in the demo. But again, just to show you, we have a catalog, you click in, click next, and that's it. That is the same experience you have in the public cloud. The other piece we want to highlight is, again, sharing the cluster resources across different technologies. So again, not just Kubernetes, but you can have Kafka, Cassandra, Jenkins. This greatly adds up into kind of your infrastructure build and helps you increase infrastructure utilization and reduce cost, which is, we have customers reducing costs over 50 or sometimes even 60%, whether it's on-premise or on the cloud. So that's a big thing that DCS provides as well, and Mesosphere provides. The third piece you want to get is the hybrid cloud, and that's something that is very unique to DCS. And everyone talks about hybrid cloud, but when we talk about hybrid cloud, what we want to highlight is like the three top use cases. First, having an edge and multi-cloud federation. You want to have a single control plane across your cluster that are spanning GCP, maybe Azure, maybe on-premise, and having that ability to have those clusters, or sometimes extending one cluster across multiple clouds, is something that we do very, very well with DCS, and that is very unique to us. The next piece about that is, again, business continuity and disaster recovery. You can deploy application to multiple clouds simultaneously, or even distributed across availability zones or racks, which greatly increases kind of the high availability of your application. And of course, the final piece is, as everyone loves to talk about it, but nobody's actually delivering on, is the cloud bursting. And you can actually easily add and remove cloud capacity to on-premise cluster. And on Mesosphere.com, we have a bunch of webinars that we talk about this in more detail. But just to let you know, that's something that you get with Mesosphere DCS, and those are some of the use cases that come in. So this is an example just to tell you a setup that has in one of our customers. So they have a DCS cluster that is spanning, but they have one cluster on the left. You have one cluster that is spanning AWS on the East 1 region in North Virginia. And part of that cluster is extended across Azure and Microsoft in the UK. And again, that's a one stretch cluster, but you get the benefit of high availability across different cloud providers and even different continents to some extent. And you can offer services available to some of these customers based on kind of proximity and geographic proximity. But at the same time, you can have multiple clusters in different locations and having a single control plane for that and a dashboard. And that's what we have. For example, you can have another cluster in Japan and APG in case the latency doesn't allow for a stretch cluster to that region. And then you can have this link control plane for consistent operation. So again, making it easy to run. And these are cloud providers. They can be on-premise. You can run anywhere. So that's up to you. Just for the interest of time, I think we can just, if we can jump into the video demo overview of DCOS, and then we can hand it over to Bala.
Hi, today we're going to give you a quick walkthrough of some of the features and capabilities of Mesosphere DCOS. Mesosphere DCOS is a cloud-scale operating system that operates all the servers in your infrastructure as one giant computer. Built on the production-proven Apache Mesos, DCOS elastically runs containers, data services, and traditional application binaries in a single unified computing environment across any infrastructure or cloud. As an operator, DCOS provides a single management experience whether you run on AWS, Azure, GCP, or on-prem using bare metal, VMware, or OpenStack. The benefits of DCOS include faster time to market of new projects, significant savings on infrastructure costs, and always available services with no maintenance windows. Let's take a look at the DCOS dashboard. The dashboard provides a quick overview of cluster health and utilization. Here we have a new DCOS cluster. Our cluster has 20 nodes, but we operate those nodes together as one giant resource pool of CPU, memory, disk, and GPU. Let's see how DCOS helps simplify application deployment. The DCOS catalog, which is part of DCOS, makes it easy to install more than 100 infrastructure and data services with a single click. For example, let's deploy Spark. Notice it took less than a minute to deploy Spark. We can also fine-tune the configuration of our services. Let's demonstrate with Kafka. When we click the Edit button, we can configure and fine-tune Kafka parameters to optimize performance and resource utilization. Note how the service is deployed, and in minutes a highly available Kafka cluster is ready for production use. We can also deploy services via the DCOS CLI. Let's deploy Kubernetes. We will use the DCOS package install Kubernetes command. If we return to the DCOS dashboard, you can see all the components required for a secure, highly available Kubernetes cluster were automatically deployed and configured in less than 10 minutes. Because we've deployed 100% pure Kubernetes, we can manage it through the same familiar Kubernetes interface. By deploying Kafka and Spark, we can see how the DCOS service catalog, with its one-click install capability, makes it easy to adopt the latest data services and technologies.
And thank you, Amar. It's great to see the benefits that are offered by the Mesosphere platform in deploying containerized applications. And you talked about especially the data-rich applications as well as containers based on Kubernetes. So now let's turn into the topic of container networking and see how Big Switch's Big Cloud Fabric has been proven to be an ideal SDN fabric solution for container deployments. Okay, so let's first start by looking at how IT is being transformed with the new cloud-native application architecture and what kind of changes they impose to the infrastructure. Amar talked about how applications are changing. Traditional applications typically run on monolithic and static infrastructure, which lack agility and are difficult to scale as businesses grow. So cloud-native applications that leverage containers have come about to make deployment more agile. They are lightweight, they're easily packaged, and designed to run anywhere, making them portable across different environments. This evolving cloud-native application architecture is demanding that compute, network, storage resources are dynamically provisioned and auto-scale as they grow. Application portability is increasingly a requirement because workloads are shifted across private clouds and public clouds. Business velocity is an imperative for organizations to stay competitive, and so speed of application deployment and provisioning becomes very critical. And all of this needs to be achieved with a flat budget, and so customers are looking for solutions with the lowest TCO. In other words, speed is the underlying necessity in the data center, speed that is driven by automation, simplicity of operations, rapid change management, and ease of troubleshooting. Now, let's look at some of the networking requirements when deploying containers. Typical networking constructs apply: the physical network, which connects servers running container applications, and which also connect to the external environment. So basically both the east-west and the north-south traffic. The virtual network, which resides inside the server host, and additionally, the typical services such as security and load balancing. Now, as containers are rapidly spun up or down, the network needs to adapt to that same rate of change. What is really needed for such a dynamic environment is really a zero-touch automation to enable networking to be dynamic and to move at the speed of applications. Also, when troubleshooting issues in such a dynamic environment, you will need a way to rapidly identify if an issue is with the application itself, with a part of the infrastructure, or with the physical or virtual network. Hence, having complete visibility of the environment and the traffic flow between the container endpoints is key for rapid resolution of issues. Application teams need an application-driven logical model for networking, a uniform model that applies across VMs, containers, and bare metal apps. In addition, service insertion mechanisms are needed as well. So traditional box-by-box networking approach is just cumbersome and effective to achieve the speed that are needed for the container-based applications. So we'll soon see why the Big Cloud Fabric is the ideal SDN fabric for container deployments in production environments. But before that, let's look at the two popular networking models that are adopted by enterprises today. First is the overlay-underlay model. That is the overlay being a network of virtual switches leveraging an encapsulation technology like VXLAN run on top of a physical underlay network. The other model is a network that unifies physical and virtual networks, provisioned and managed as a single logical entity. Now, Big Cloud Fabric can be an effective networking solution with either of these approaches. In the physical-only approach, Big Cloud Fabric brings all the benefits of automation and visibility to the physical network. And in the unified physical and virtual approach, these same benefits are extended to the virtual layer as well. And the control and management of both layers are unified. Now, let's take a look at the solution in more detail. Now, as I mentioned, Big Cloud Fabric, is the ideal SDN fabric for deploying containers, and it brings that agility and simplicity to deploy it at the speed of apps. So the physical network itself is a leaf-spine cloth fabric of open networking switches managed by a central SDN-based Big Cloud Fabric controller. Now the solution offers a vendor choice of open networking switches. We support Dell EMC switches, HPE, and Acton as the supported platforms for building the physical network. And for the unified physical plus virtual fabric, the SDN controls are extended to the virtual switches, which are essentially user space agents running on top of OVS running on the host. There are no complex protocols that are run within the fabric, and the centralized SDN controller acts as a single pane of glass to make the entire fabric look like a single logical switch and manage it as a single unit within the network environment. The BCF controller also acts as a single point of integration with Mesosphere container orchestration system. So the container network automation happens with an agent that runs on the controller and a CNI-based container plugin that runs on the hosts. So when a container is spawned, the networking for it is automatically taken care of across the network infrastructure under the domain of the controller. And you will see, I'll get into more details on how that automation and what are some of the aspects of that automation. And as we talked about earlier, given this dynamic nature of the environment, this dramatic simplification of network operations is very essential. And visibility is a very important benefit that we get with this approach, as network admins get a view of all the container endpoints, and troubleshooting becomes extremely simple with an end-to-end path visibility from one container to another. So the entire experience that application teams desire to provision and manage the networks at the speed of containers can now be achieved with the Big Cloud Fabric Mesosphere joint solution. Now let's look at how Big Cloud Fabric container networking automation really benefits IT teams to achieve rapid and agile container deployments. Now, when hosts are running, containers are connected to the leaf switches of the Big Cloud Fabric. They are automatically detected and admitted into the fabric through automatic formation of lags, or the link aggregation groups. So in this way, the entire fabric is stood up in a zero-touch fashion. And in addition, the Big Cloud Fabric dashboards show the host as part of the appropriate interface group of the fabric. So there's no manual work needed for this, and it's completely automated and saves operators a ton of time and by alleviating any of these manual operations. Next, when a new container is created, it is automatically added to the corresponding layer 2 network. And if one does not exist, the network segment is automatically created. And then the Big Cloud Fabric controller also provides visibility into container endpoints that are dynamically learned via the container orchestration system. So details such as the container name, description, the tenant information, segment information, network constructs such as IP, MAC, vSwitch. So all of this information is available at the fingertips of the network admin.
Right. Bala, we have a question here.
Okay.
Often we hear about network problems being very difficult to troubleshoot. Does BCF have tools to simplify troubleshooting in a container environment?
That's a great question, and I completely agree that one of the biggest problems with networks today is troubleshooting the issues, network issues, right? And especially in a dynamic container environment, this problem becomes even more complex. So let's look at how BCF actually does this, right? It actually provides a very valuable tool called Fabric Trace feature, which really simplifies troubleshooting. Now, what happens is with this, the network admins can do a connectivity test between any two container endpoints with just a few clicks on the controller. Now, once you provide the container endpoints, an end-to-end fabric view of the path is provided by the GUI from the source container to the source vSwitch, leaf, spine, destination leaf, destination switch to the destination container. Now, this kind of visibility is possible only because the Big Cloud Fabric controller manages the entire fabric and has a view of the entire fabric in a single pane of glass. And this really simplifies the operations as it completely eliminates the complex box-by-box CLI hopping, which is typically a painful troubleshooting experience with traditional networks. And another important feature which Big Cloud Fabric has is extensive analytics that is made available in the analytics dashboard. This has various information across the fabric and has historic report of all events, statistics, as well as customized information related to container networking. The dashboard has a graphical view of all container events. You can get granular details by zooming into specific historic time windows to get event details corresponding to that time window. And with containers, things are ephemeral; they come and go, right? So it's very important to get this historic view, and you can also get individual event details for specific events from this dashboard. With that, I'd like to turn it over to Don to take us through a demo of the solution.
Thank you, Bala.
Hello everyone. For today's demo, I have the following physical topology setup. I have Big Cloud Fabric deployed with 3 racks, and servers are connected to the BCF top of the rack switches. I have a DCOS cluster set up in here. I'm going to bring up couple Nginx containers on DCOS first, and then going to bring up Kubernetes on top of the DCOS. Just like the way DCOS abstracts the compute environment, you will see how Big Cloud Fabric abstract both virtual and physical networking and present the entire networking environment as one big switch.
So let's go ahead and log into the DCOS. If I go to the services section, you will see I don't have any services running right now. And in the node section, you will see I have 3 agents running. So now let's go into to the big cloud fabric itself. Let's go ahead and log in. Homepage gives a user a quick snapshot about the whole networking environment, top talkers, top usage, etc. So in BCF, you don't do traditional box by box networking. The entire network is considered as one big switch itself. We group all the physical networking components such as switches, interfaces under this fabric tab. Then we abstract all these components into a logical tenants and segments. Under the visibility tab, you will see visibility and troubleshooting options. So what we will do now is go ahead and click on the fabric and take a look at the whole big cloud fabric itself. Here we have two big cloud fabric controllers in active standby fashion, and I have two spines and top of the rack leaf switches. So all the way to the down, we have the virtual switches that are running inside these DCOS agents. If we click on one, we will see more granular details about the networking inside these DCOS nodes. You will see the uptimes, and most importantly, you will see any other problems in the DCOS nodes. In this case, such as disconnected links. You can click on any one of these other DCOS nodes and get the same level of information. So you see how exactly we are presenting the whole network as a one single big switch. If we go into the interface group, you will see Big Cloud Fabric has automatically discovered all the DCOS nodes in this setup itself. If we expand, we will see where the things are getting connected. Let's go into the tenant section. This is where the DCOS cluster mapped to a particular tenant, which is a routing domain itself. If you go inside the tenant itself, you will see brief usage stats and extra components such as logical segments, policy list, and you can enable different routing protocols on here as well. So what we do now is we'll go back to the DCOS and try to quickly deploy an application. We will go to the services and run a service using a quick JSON file and deploy a couple Nginx containers. So we will change the network to BCF and segment to Nginx and quickly run the service. You will see the containers getting deployed, and once it's done, we will go back to the Big Cloud Fabric, and now if you hit the refresh on the segments, you will see Nginx segment got automatically created over here. If you go inside this Nginx segment, you will see how the things are getting automatically discovered. BCF automatically figured it out which host these containers coming from, and what are the IPs and all the automatic IPs and across the entire network in here. We will verify the connectivity in these containers a bit later with Kubernetes cluster, but now let's go ahead and scale up these services to 4 instances. And you will see how Big Cloud Fabric automatically reacts to all these scale up, scale down events. If you hit refresh, you will see the endpoint count has changed. And if we hit refresh over here, you will see the extra nodes got added. So what we will do is, at this point, we will go to the and create a Kubernetes cluster on top of DCOS. We'll go to the catalog, and all we need to do is change the provider to the BCF itself. We can quickly run this Kubernetes cluster. And once the cluster is up, let's go back to the Big Cloud Fabric and verify. And you will see the Kubernetes default segment got automatically created over here. So which means the connectivity is already established between the DCOS and Kubernetes clusters. So we will go into and log into the Kubernetes cluster and try to create an application. If you do kubectl get nodes, you will see 2 KAIDS nodes in here. Now what I'm going to do is I'm going to quickly deploy a simple app called hostnames in this cluster. All this does is it responds with its hostnames. I'm going to create 4 instances of this, and I'm going to create this inside a namespace called hostnames. So it looks like the pods might have got created already. Yeah. And we will go back to the BCF and verify the hostname segment is there. And then we will come back and verify the connectivity. To verify the connectivity, I will create a simple curl pod where I can do curl to these services, to both the Kubernetes service as well as DCOS service. If you look for the service cluster IP for the hostname service, and then we will go inside the curl pod and try to curl this cluster IP itself. And you will see we are getting responses from different pods, which means connectivity is established between to all the pods itself. Now, let's try to access that previously created Nginx app. If we go back to the BCF and go inside the Nginx segment and grab an IP of that Nginx container, and if we curl this IP, you will see we are getting a response from Nginx server itself. So which means that end-to-end connectivity is established. So this is how easy it is to get the connectivity going with BCF. But how about day two problems such as troubleshooting and visibility? So this is where BCF can provide whole new set of tools specifically designed for containers. For example, let's say we want to troubleshoot connectivity between this Nginx container and another endpoint. All we need to do is click on the endpoint and do a test path. This will take you to the BCF test path utility. The source is set right now. All you have to do is pick a destination. You can pick any endpoint as your destination in here, either a virtual machine or a bare metal device or a container itself, and we'll pick a hostname container we just spawned. You have two options with test path once you select this destination container. You can hit simulate button and get a logical trace of the text path. This will tell you from the controller point of view whether the traffic is going to get forwarded or not. For example, if your connectivity is getting blocked by a policy, security policy, this will right away tell you that. The other option is to run a test to look at the real packet path between these two containers. You can initiate a fabric test, and you can either catch a real traffic pattern between these two containers, or you can actually tell the BCF controller to inject the packets on behalf of these containers. This is a very huge differentiation in Big Cloud Fabric. You can pick any frame size, and when you hit submit, controller will put this packet to the wire on behalf of the containers and try to trace the whole traffic path across the entire virtual and physical network. As you can see, we got the full fabric trace back, and it lists all the network hops. Traffic started from the DCOS node 1870 and got into the leaf switch R3L2, and it got all the way down to the destination node 1857. Next, we will take a look at how to put security policies between these two container clusters. In BCF, you can put a policy to deny traffic from a container app cluster to another app quite easily without worrying about any network parameters. If we hit a simulate over here, you will see the traffic is right now getting allowed by this default permit rule. So let's go ahead and edit this rule to block traffic from this Nginx cluster in DCOS. We will go inside the DCOS tenant and edit the policy list to deny traffic from the Nginx services. So if you hit edit here and add a security rule saying just deny any traffic from this Nginx pod, and it's pretty much that that action will take care of the whole security parameters that are coming out from this Nginx cluster. We will put another rule to allow all other traffic. So it's permit any kind of rule. If we hit save and apply the security policy as an inbound policy, and the traffic would get denied. To verify that, we will go back to the test path itself and hit simulate, and it says getting denied and dropped. And if we go back to our curl pod and verify the connectivity, you will see we are not getting to connectivity to the container anymore. So apart from these tools, Big Cloud Fabric has tools such as span, where you can span your container traffic environment on demand to any destination. Big Cloud Fabric also comes with built-in analytics module, where we try to give more service level visibility into the container environments. All you need to do is to go back to the Big Cloud Fabric and click on the analytics and navigate to the inbuilt analytics web page. If you go down and click on the container section, you will see a lot of analytics details about the DCOS cluster. You can zoom in and out from time frames to get historical details and a lot of other service visibility information. So this pretty much concludes my demo, and back to you, Judy.
Thank you, Don. I think that was excellent. Bala and Amr, thank you very much. I think that the information and the update overview was really quite excellent. So we're moving into our Q&A section, and just as a reminder for folks on the phone here on the webinar, You can put your question in the question dashboard on your webinar dashboard, or if you're listening on demand, please send us the question at info@bigswitch.com. And just a little reminder, don't forget to download the handouts we have. So there's one question that I think we can start with that is about sort of the size and scale. So what are the typical cluster size for new customers? And part two of that is, do you see any industries or applications that are leading in container deployment? And that's, maybe let's start with Amr and then go to Bala.
Yeah, so that's a great question. So we see customer typically start with like medium-sized cluster, like we're talking about 50 nodes maybe sometimes. But once they get the hang of it, they understand how things work, they rapidly expand to 100 or sometimes even 300 nodes, sometimes even reach 1,000 with DCS, depending on some other workloads they do as well. So that the other thing is we're seeing a lot of financial services kind of adopting this, and this was surprising because financial services are some of the most kind of conservative industries. We're seeing a lot of traction, a lot of innovation coming there. So that's something we're seeing. Also, of course, infrastructure and software, SaaS companies, software companies are also early to adopt containers and microservices.
Yeah. So in our case, we have seen container adoption for our solutions across, very different segments. So one of them is a modern, automotive company, right? So that is sort of, you would think, as a new age company. But at the same time, we are also seeing adoption with a very traditional transportation company. So, I mean, it's running across, wide gamut.
Good. Great. Okay. I don't see any other questions from the audience right now. And so let's segue into sort of closing and letting folks know how they get started. If something we talked about today has piqued your interest or you want to learn more, just head over to our website, bigswitch.com, or again, you can send us an email at info@bigswitch.com. There's a pretty straightforward path to get started, either through our labs environment, which makes it super easy for people to get started with our solutions. There are several resources you can download or watch that will give you a tour of our products. There's also particular information on Mesosphere as well in our tech partner section. In your handouts, you'll find live links, and you can click on any of these resources listed, as well as the resources from the panel that we have on the dashboard today. With labs, you can experience Big Switch bare metal SDN solutions firsthand right on your laptop, and have had great success with folks actually setting up sandbox environments of their own to test drive the solution using Big Switch, Big Cloud Fabric, and Big Monitoring Fabric products. So please visit labs.bigswitch.com and download the handout for more detail. We invite you to check out our on-demand webinars, including most recent webinar with Aaron Baillo, Managing Director of Security Operations and Architecture at the University of Oklahoma. Aaron shares how Oklahoma University improved network security and achieved greater visibility at nearly 50% the CapEx savings. Our next webinars coming up will be posted on the website. And that concludes our presentation today. Thank you so much for joining us. Have a great day, great evening, and until next time, thank you.